Hello, good day viewers. Welcome to another biology presentation. So in this presentation, we are going to look at biology paper 2 for 2005 question 9. So let's look at the questions now. So we have question A, B, and under question B, we have question E, Roman numeral 1 and Roman numeral 2. So we are going to start with question A. What is mutation? So here is our question A. What is mutation? So we understand that mutation can be defined as a permanent change to the structure of chromosomes or DNA of a gene. So that is what mutation is. So mutation is normally caused by physical environmental factors such as radioactive decay, ultraviolet radiation, and ionizing radiation such as X-rays, gamma rays, and alpha particles. It can also be caused by radioactive chemicals. So we have said mutation is a permanent change to the structure of chromosomes or DNA of a gene. So that was the answer for our question A. So we now move on to question B. So under question B, we are looking at albinism is recessive to normal skin color using the symbols capital letter M and small letter N for the two alleles. So here we are going to use the capital letter M and the small letter N. These letters are representing the two alleles. So here we need to understand what albinism is. Okay, so albinism is just a condition in which a person has little or no production of the pigment melanin. So this pigment melanin is just a pigment that is able to determine the color of the skin, hair color, and the color of the what? Of the eyes. So if this pigment is lacking in an organism, a person is going to become an albino. So this is why I'm saying albinism is inherited. It's a recessive what? Disorder, meaning that a person has to receive two recessive alleles, one from each parent, in order to have albinism. Now, since we are having these two alleles, capital letter M and small letter N, the capital letter M is dominant. So M is dominant and the small letter N is what? Recessive. So in order for us to answer question B1, show how one normal couple might have an albino child. So this couple was normal, meaning that the male was heterozygous and the female was also heterozygous. They were both carriers but normal. So what would be the genotype of the normal male? So the normal male is going to have the genotype which is MN, capital letter M and small letter N. Then the normal female is going to have capital letter M and small letter N. So both of these are normal. So let's look at how we can now answer this question. So to answer this question, we are going to need 5 stages. So the first stage is going to be the parental phenotype, of which the parental phenotype we have said you are going to have a normal male that will be crossed with the normal female. So here we have normal male crossed with the normal female. So don't forget to put the cross sign here under the parental phenotype. The second part, we are going to have the parental genotype. Okay, so we are going to have the parental genotype where we have MN for normal male and MN for normal female. So apart from the parental genotype, we are going to have the gametes. So these gametes are going to separate so that we do random fertilization now. So our gametes, we have MN, another MN, so they have just separated. Okay, so we need to now do the random what? Crossing. So let's cross them and see what you are going to have. Here we are now going to do our crossing. So we are going to have our first crossing right here. This one will be crossed with this one. So we are going to have M. Then this one will also be crossed with this one. So we are going to have M, N. Then this one will be crossed with this one. We are going to have M, N. Then this one will be crossed with this one. So we are going to have N, N. So this that we have gotten now, this is the F1 offspring. So don't forget to write this. This is the F1 offspring what? genotype. Then from here we need to come up with the F1 offspring phenotype. So under the F1 offspring phenotype, so we are just going to denote this phenotype using the genotype. So here the genotype is MM. So remember we are looking at albinism. This is normal, okay, because M was dominant. This is normal. Then here again MN, this is normal as well. Okay, M is dominant. Okay, again we have MN. This is also normal. Okay, then here we have NN. So here we have homozygous recessive. So this one is the albino. Okay, so we have answered our question. So this is how we can come up with the genetic crossing. So let us now look at the second question, which is the last one. So this is our last question. What is the probability of them having an albino child? So what is the probability of the couple having an albino child? So let's take a look at this diagram. We can see that this couple had 4 children. Okay, so from these 4 children, only one was an albino. This one, okay. So we will say the probability of this couple having an albino child, you come up with the probability is equal to, we will say 1 is the one who was an albino out of 4. So this is our probability. We can leave it as percentage, where we can say 1 out of 4 times 100%. So here 1, here we are having a 25%. So 1 times 25 to give us 25%. So these were the answers to this question. So we've come to the end of our presentation. Thank you so much everybody for having time to view this content. This has been your presenter, Mr. Mlenga. Bye bye.